Okay, so this is going to be a quick video on present and future value diagrams. We're not actually going to do any formulas or anything like that today. We're just going to look at a diagram. So what's the future value of $2, you're a poor man, at 5% per annum compounding monthly over 20 years? So when we create our present or future value diagram, what we're going to do is draw a straight line. Here's the present value over here. Here is the future value. Now, this could be called year 0. It's important that you start at year 0. Think about it for a minute when you put it in. No years have elapsed. And at future value, that's after 20 years. Now, we could have also phrased this question as like put some money in the account in 1980 and pull it out in the year, 2000 or whatever. And that could have been 1980 and that could have been 2000. Whatever, I don't really mind. 0 to 20. Now, the present value here is $2. And the future value, we don't know it. That's the question. You're probably looking at this diagram and going, duh. Yeah, okay, duh. We're going to look at some slightly more difficult ones just in a moment. Okay, here's the reverse of this question. How much started in the bank if you have $100 after 15 years? Again, we can draw our diagram. Year 0 is over here, and after 15 years, so year 15 is there. Now, we know that our future value, this is future value over on this side of the diagram, we know what that is. That's going to be $100. But what we don't know is this, the present value. Okay, so you can see one question is just the reverse of the other. Here we're looking at, okay, $2, what will it eventually become? And here we're looking at $100, what was the value of that in the past? I'm just gonna wipe all this off and show you one more awesome thing, and you're gonna go, whoa. So this is the bit where it starts getting tricky. With the other stuff, it's really, really simple. You're this one-dimensional character that puts a little bit of money in a bank account, and then you never earn any more money, you never save anything else. You just put the money in the bank account, you wait 3 years, or you wait 5 years, or you wait however long, and then you're done. With a question like this, make a deposit at the start of every month for 3 years. How much at the end? I better add just a little more information. Make a deposit at the start of every month for 3 years of, let's say, $200. So you're saving, you're a pretty smart guy, every month you're saving $200. We start here. Now, at the start of every month, so that means at the start of month, well, at time 0, you're going to put in $200. But you're also going to put in $200 at time 1. And you're also going to put in $200 at time 2. At time 3 and 4. $200. You get the general idea. This goes on and on and on and on and on, all the way up to 36 months, 3 years, where you're going to put your final $200 in here, because remember it says you're putting it in at the start of every month. So you put $200 in here. Now this really, the question that is being asked is how much money will be in this bank account at this point. The question is, what is the future value of all of these individual payments over 3 years? How much will that add up to? It's a difficult question because this is going to get a certain amount of interest. That's easy. This is going to get a certain amount of interest, but a little less. This is going to get a certain amount of interest, but a little less. The way that you really think about it is that each of these $200 is like an individual bank account. So $200 for 3 years, or 36 months, $200 for 35 months, $200 for 34 months, $200 for 33 months. You could do, if you wanted to, 36 different compound interest questions, 36 of them, add them all together, and you'd have the final answer. You could do that really fast using Excel or a calculator or something. Oh, well, probably not a calculator, but using Excel, you could just create some formulas, drag and drop it, and you'd have your answer. You have already looked at geometric progressions, so you know that there is a way to add up something like this, because I don't want to get too far into it, but this is just a geometric progression. The ratio from each, the ratio of each future value to the previous future value is a defined feature. It's the interest rate. This video isn't about doing that math though. This video is about drawing these diagrams. You're definitely going to be asked to draw diagrams like this, and it's certainly important because you're going to have to be able to draw these diagrams to understand the sort of questions we're going to be doing. There is one more type of diagram you probably need to take a look at. This is the last one. It's the Set for Life Scratch It. You guys have probably heard of this. You like do the little Scratch It card, and then if you win, you get $25,000 every year for the next 20 years or something like that. Now, this is sort of the opposite kind of question, because I guess the question is, what is the value of that what is the value of that prize today? So if the Instant Scratch It company said to you, oh, look, this is $25,000 a year for the next 20 years, that's going to be a pain for us because we're going to have to keep giving you that money over and over again. How about we give you a certain amount just today? The question we'd be asking is, well, what is that certain amount? What is $25,000 worth? $25,000 every year for 20 years worth today? So they'd probably be paying you at the start of every year, so they pay you $25,000 straight away. Oops, let's try that again. At time 0, they pay you $25,000, and then at year 1, they pay you $25,000, and at year 2, they pay you $25,000, and even at the end here, this is at the start of year 2020, they pay you $25,000. And the question we're asking is, if we found the present value of each of those amounts, we could then know what the value of a Set for Life Instant Scratch It would be. How much could they pay you out for and not do that instead? Okay, there's quite a bit of stuff there. All you really need to take away from this is an ability to create these diagrams. Present value here, future value here, put the years in there and the dollars in the bottom. Good luck.